Everybody. So today we're going to be working on a lab, which will be a little weird to do online, but we're going to attempt it. So this lab is about the volume of a box that we can build. Okay, so if you can, go get an 8.5 11-inch sheet of paper. 8.5 11 is like standard computer paper size. If you don't have this fat paper, you can grab a sheet of paper that you already have, or just watch me if you would prefer. That's totally fine. So I'm just going to talk through this lab. So what I would have done is I would have assigned you each a group, and you each would have done one of these boxes. Okay, so obviously that's not going to happen. So you can just pick a particular size, and then you can follow along and just cut out this particular size square from your corners. Okay, so in this lab, we're going to be answering the question, what is the largest volume of an open top box that you can build from an 8.5 by 11-inch sheet of paper? Okay, so you'll each build a box, and the directions for creating this box are going to be right here. You're going to cut a square from each corner of the paper. Now, the square is going to be whatever length you pick from this table down here. So I picked to do a 1-inch by 1-inch square from each side. So each of these lengths right here are 1 inch. So I'll show you what that looks like on your paper. So fold it out. You would measure out 1 inch, measure up 1 inch, and you would cut this little square out of the paper. Grab my square. So would have measured and just like cut that straight out of the sides. You're going to do that on all 4 corners. Okay, so let me zoom out a little bit so you can see. So you would be cutting out all 4 of the corners from your paper. Oh, that's really blurry. Let me fix that. And notice that this paper used to be 11 inches long, but we cut out 1 inch out of either side. So we subtract 2 from that 11 inches to get 9. So now this length right here is 9 inches. It used to be 8.5 inches long, but again, we cut 2 inches, 1 inch from either side to get this length as 6.5 inches. So now when we fold up our sides and tape them together like I did this one corner right here, you're going to get a box that is 6.5 inches wide, 9 inches long, and then this value right here happens to be an inch because that's what I chose to cut out of my box. If you chose a different number, then your height, I guess, will be a different value. Okay, so now what we want to do is we want to, let's see, I guess I'm going to write this out right here. So we had 11 total inches. Here, we had 8.5 inches here. And then I happened to pick, oh, let me zoom in for a second. I happened to pick 1 inch by 1 inch squares, but you didn't have to do that. You could pick any value. I'm going to represent any value that you could have picked by X, okay? So now what we would have done is I would have asked you to find the volume of this open lidded box for each of your groups. And so we're going to go through what the volume would be for each of our values. So for group 1, which cut out a 0.5 inch square, your volume, so we're taking 0.5 inches off of each side. That means, so this would be 0.5 and this would be 0.5. So we're taking it off twice. 0.5 is like a half, right? That's a half an inch. So we're taking off a full inch from each side. So instead of 8.5, I'll have 7.5. Instead of 11 on this side, I would have 10. So I'm taking off an inch. And then my height would be 0.5 because I only have a half an inch as my height. When you multiply all those values together, you should get 37.5 inches cubed. Okay, we would do this again for an inch. So we already talked about, because I cut an inch out of each of my sides, it would be a 6.5 by 9, because we're now taking 2 inches out of the total length, and then 1, which would give us 58.5 inches cubed. Let's go through again. We would get 5.5, 8, 1.5. If you want to skip this part, you can just jump to the solutions page, and it'll show you all the values and all of these products that I wrote out. Try to make sure you understand exactly where I get these numbers from. Try to figure it out. Let's see, then 5 is going to be 3.5. And if you have questions, post to the discussion board. If you're confused about how I got numbers for any of these values, write it out, and I will answer those questions in a little video. I'll write out the solutions for you if you need. So this was 37.5 inches cubed. 1.5, 4, and 3.5, which gives us 21 inches cubed. Oops, didn't mean that little c. And lastly, you have 0.5, 3, 4, which is going to give you 6 inches cubed. Now, if you'll notice, our values for volume went up until right about here, and then all of a sudden they start going down. Okay, so somewhere in between here, we are going to hit a maximum value for our volume, which is what the question at the very beginning of this lab is asking. So we've tested specific values, but the actual maximum could be anywhere between these 3 values. We just know that it's going up between here and here and going down between there and there. So anywhere between 58.5 and 63, we will hit our maximum. Also notice that once I start cutting, there is a limit to how far I can cut in. If we go back up to this picture right here, if I make my X bigger and bigger, eventually I'm going to meet in this middle place right here, right? And I'm not going to be able to make a box. So there is a limit to how big the square is that you can cut out. And that's going to define our domain for our box. So basically for our domain, we have to have that the size of our paper, the length, 8.5 or 11, minus 2 times x has to be bigger than 0. So this is going to be the same for both of these. Okay, in either case, we have to have a value bigger than 0. So we can solve each of these inequalities. So I'm going to take 8.5 minus 2x greater than 0 right here. I'm going to subtract 8.5 from each side. And I'll get that negative 2x is greater than negative 8.5. And then I would divide by negative 2 on both sides. Divide by negative 2, divide by negative 2. And I would get, I'm going to write it out over here, that x, so when we divide by a negative, it flips the inequality sign. We would get that x has to be less than positive 4.25. Okay, now let's check the other one and see what happens. So we're going to have 11 minus 2x is greater than 0. Subtract 11 from both sides. Negative 2x is greater than negative 11. Divide by negative 2 on both sides. And remember, when we divide by a negative with an inequality, it's going to flip the sign. So we have x is less than 11 over 2 is going to be positive 5.5. So we have that x could be less than either of these values, but we need to pick one. Okay, we are going to pick the one that is more limiting, which happens to be this one right here. Okay, if we cut more than this, it'll be fine for the longer side. But if we cut this amount, all of a sudden our shorter side is going to be non-existent. So we have to limit it with the smaller value. And we also, in order to make a box at all, we have to have our x be strictly greater than 0. Okay, so our domain for this is going to be x has to be between 0 and 4.25, okay? And this would change depending on the original length and width of our box. You would just change these numbers right here and then solve the same exact inequality. Okay, so let's see, and let's go ahead and write out this one right here was 8.25 minus 2x. This was our x, and then this side right here is our 11 minus 2x. So I'm going to go ahead and highlight those so that you guys can see. Let's see, I need this and this. Which side I'm actually referring to. So this side right here was the 8.5 minus 2x, 11 minus 2x, and then x minus x is the height. Okay, so that's exactly what we're talking about there. Okay, so that's this front page. I'm going to make a separate video for the back page so these videos don't get too long. So I'll be right back.